Hello friends, welcome to all of you. Let us see another question on nodal analysis. This question has been asked in GATE 2023. The question says that in the circuit shown below, the current I flowing the 200 ohm resistance. So what will be the current I in this 200 ohm resistance value? So let us see how can we solve this question. So this is the circuit given. As we can see that all the resistances in kilo ohm and voltage is in milliampere except this resistance which is given in ohm. So we will convert this ohm resistance in kilo ohm so that there should be no fear of any mistake during solving of this question. We have converted this in kilo ohm. Now during our solution of this question, we have to not worry about the unit of the question. All the resistances will be in kilo ohm, voltages in volt, and current will be in milliampere. Now we will consider this node 1 and this is the node 2. Let voltage of the node 1 is V1 and voltage of node 2 V2, and this node is assumed to be grounded as according to nodal analysis. Now apply nodal analysis at this node 1, then we can see that at this branch what will be the current. The current direction is not known. Let's assume current will be flowing outwards. So in this direction current will be flowing. So here we can write V1 minus 2 whole upon 2 divided by resistance. So this is the current flowing in this branch. As here is a voltage source, if positive sign is towards the node, then we write V1 minus 2. This is the equivalent voltage of this branch. If negative sign is towards this branch, then we will write it V1 plus 2. So it will be easy during writing the KCL if we remember this concept that if plus sign is towards the node, then voltage will be V1 minus 2. If negative sign is there, then towards the node, then it will be V1 plus 2. Now in this branch we can see that current is not known, so let's assume the current will be outward. Then what can we write? V1 by 2. So here plus V1 by 2. Now current in this branch is coming towards the node, so it will be negative in sign. This will be minus 1. In this branch current is flowing outwards from this node, so here will be plus sign, plus 1. This is plus 1. Now in this branch we don't know where in which direction the current will flow, so assume outwards from this node. So and then current value will be V1 minus V2 upon 1. Then this is the written here and equal to 0. So this equation can be find out. If we rearrange this equation, then we find out this equation. Let's see how can we apply KCL at node V2 and node 2. Then this current 1 milliampere is coming towards this node, so we can write as minus 1. So it is minus 1 milliampere, and we don't know current in direction, so we assume that current will flow outwards from this node. Let's assume it will flow outward from this node. Then what will be value of current? V2 minus V1. Then V2 minus V1 by 1. Here it is written V2 minus V1 by 1. In this branch what will be the current? V2 upon 0.2, then plus V2 upon 0.2. Since current is flowing outwards, we have an assumption about it. Then this will be equal to 0. This equation will be rearranged and this equation will be found. So equation 2 has been found out. Now we will solve equation 1 and equation 2. After solving equation and equation 2, we find out voltage of V2 equal to 3 by 11 volt. As we can see from the circuit that current I equal to V2 by 0.2, then put these values and we get I current value is 1.36 milliampere. So in this way we can find out the value of current I is equal to 1.36 milliampere in this question.